Hello guys, welcome back to my YouTube channel. Today I am going to solve day 21 problem of this month on LeetCode. If you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's start with our today's problem. So in this problem we have given two integers left and right that represent the range. Okay, left and right, so both are inclusive here, closed brackets are there, and we have to return the bitwise AND of all the numbers in this range inclusive. Okay, so one basic approach that most of the new beginners will try here, they are going to just perform the AND operation for all the numbers between left and right. So let's say they are going to perform the bitwise AND operation between 5 and then 4 6 and then 7. Okay, so in this case you will get output. Okay, you are just going to run one for loop from the left and till right, and you are going to perform the AND operation between all the numbers and storing the result one by one. Okay, so this approach will work for example 1, example 2, but this approach will definitely fail for the example 3 because the number size is, see here, the left right is less than equal to 2 raised to power 31 minus 1. So you can't run the loop now for all the numbers. Okay, so this approach is not efficient, and definitely you will get like time limit exceeds, errors like that. Okay, so there is one more easy approach to solve this problem. Okay, so let's say okay, let me show you one examples here. So I have copied all the examples here in this sheet. So this is our first example. Left is 5 and right is 7. So here in the binary form I can represent a number like this. Okay, so this is nothing but 1. Okay, let me change the pen. 1, this is 2-bit, this is 4-bit, this is 8-bit, 8, this is 16 position, this is 32. Okay, 32, this is nothing but 64, and this is 128. Okay, so this is how bits are represented for a particular number. Okay, so in this case a number is 5 given to us, right? So 1 is represented like this bit is set to 1 bit, and this fourth position, this 1 2 3 position is set to 1. So this is how 5 is represented in the form of bits, and this is how 7 is represented in the form of bits. Okay, so I hope that you guys are clear. So here let's say we have numbers, let's say 9 given to us. Okay, 9 is a number, and we are going to, let's write this 9 in the form of bits. Okay, so this is the form. Okay, 1 2 4 8 16. So for 9 I have to set this 1 bit, this to 1, and here at this position I need to set 1. Otherwise all other positions I have to just add 0. So this is how we can represent 9 in the form of bits, right? This is the way. So I have set this position to 1 and this position to 1, so total I get the sum as 9. Okay, so this is nothing but 2 0 position, 2 of 1. So I hope that you guys are clear with this these things, right? 2 raised to power 3, 2 raised to power 3, and this is 2 raised to power 4. Okay, so this is how I am writing 5 in form of bits and 7 in form of bits. Okay, so here in this problem we have to find the common prefix. So here see, all the bits are matching, 0 0. Here all the bits are matching, all the bits are matching, all the bits are matching, all the bits are matching here, all the bits are matching here, all the bits are matching here, all the bits are matching here. This bit is matching 0 0, this bit is matching 1 1, and after that these last two bits are not matching, right? These last two bits are not matching, these last two bits are not matching, right? So these two and these two last two bits are not matching, otherwise all the other prefix bits are matching. Okay, so here what I did, I have write here in the prefix I write all the bits, so these prefixes are matching till here, and in the end I have added 2 0 0 because we don't need these two bits. Okay, we need till the common bit found. So here this is the common bit 1 1, and after that bits are 0 1, so not matching. Okay, so not matching, so we don't need to add them. So here what is the output? This is nothing but 1 2 4. Okay, fourth bit is set to 1. Okay, fourth, this one. So here I am returning as 4. Okay, so this is the next example. 6 is represented like this, 7 is represented like this. So here all the bits are matching till here. Okay, till here. except last bit, all the other bits are matching. Okay, so here I have written like this 0 1 1 0. Okay, so here what is the output? Okay, ignore this. So here what is the output? 1, this is 1, this is 2, this is 4. Okay, 4 plus 2 6, only these two are set to 1 na, right? So output is 6. Here in the last example, so here I have converted this decimal value to the binary value. So here binary value is represented like this, and here from the left I started, so this bit is matching. Yes, after that from here these two bits are not matching, so we need to cancel out everything. Okay, so these two bits are matching 0 0, so output is going to be 0 only. For this case output is going to be 0 only, because there is no bit matching for this, because 0 0 is here. After that all the bits are mismatching, so I have to write like 0 0 0 0 0 0 0 0 0 0, and in the end output it is going to be 0 0 0. Okay, so this is the case. Okay, so how we are going to solve this problem? So let's say I have two numbers. Let's say left left is equal to 9, and right is equal to 13. Okay, right is equal to 13. Okay, so left, so these are the bits format like 30, 64, 32, 16, 8, 4, 2, 1. So this is how we are going to represent bits, right? So here 9 I can write 9 like this: 0 0 0 1 0 0 1. This is 9. Now let's write 10. So how I'm going to write 10? So 10 can be written like this: 0 0 0 1 0 1 0. And how I'm going to write 11? So 11 will be written like this: 0 0 0 1 0 1 1. And how I'm going to write 12? So 12 can be written like this: 0 0 0 1 1 0 0. Okay, and 13 can be written like this: 0 0 0 1 1 0 1. Okay, in this way I'm going to write the numbers, right? So this is nothing but 9, this is 10, this is 11, this is 12, and this is 13, right? Okay, so now let's perform AND operation between all the numbers first. AND operation. Okay, AND operation between all the numbers. So all the bits are set to 0 0 only. All are 0 0, all are 0 0, all are 1. Okay, so let's write 1. So these are zeros. Okay, if any bit is 0, then I have to just return 0. All are 0. Okay, I have to return 0 only, because any one bit is set to 0, then I have to return 0 0. So what is the output here? Only this one, bit is set at position 8. Okay, at this number 8. So output is going to be 8 in this case, right? Because if I perform the AND operation between all the numbers between 9 and 13, then only this bit is set in the result 1. Okay, all other bits are 0. Okay, so how we are going to solve this using our code, because we don't want to write for find for all the bits. Okay, for all the numbers we are not want to perform the AND operation between all the numbers, because in that case time limit exceed error will come for the larger numbers. So here what I'm going to do, I'm going to just take one left. Okay, so can I write my left like this? Okay, so here these are the numbers: 64, 32, 16, 8, 4, 2, 1. Okay, and I can write my 9, that is my left. Okay, left like this: 0 0 0 1 0 0 1. And my 13, I'm just going to write my left and right. So right is 13 now, so I can write 13 like this: 0 0 0 1 1 0 1. Okay, so now what I'm going to do here, I'm going to use one more variable called shift. Okay, in this I'm going to count how many times I am performing the right shift. Okay, so here, see here what I'm going to do. See, okay, so here what is the value of my left? What is the value of my left in the starting? It is 9. And what is the value of my 13? My right, that is 13. So I am going to run one while loop, and in the while loop I'm going to check whether my left is not equal to right. If this is the case in while loop, if my left is not equal to right, then I have to perform the right shift operation. Okay, so I have to perform the right shift operation. So what I'm going to do, I am going to right shift the bits of left by 1. Okay, left shift the bits of left by 1, and right shift the bits of right by 1. Okay, right by 1. And I'm also going to make a count how many times I am performing this shift operation until I get the result as left is equal to right. Okay, so here what I'm going to do, I am performing right shift, okay, for the left. So this is left, so I am performing right shift. Okay, so all my bits are going to move one position right. Okay, all my bits are going to move one position right for both left and right. Okay, so this is the normal case, so this is going to happen. So what I'm going to do, I'm going to delete this last. I have deleted this one. So now my numbers becomes like this. This is 1, this is 2, this is 4, this is 8, this is 16, this is 32. Okay, so now I have deleted this last. I have reset the bit. Okay, so now what is my left? So now my left is 4. My left becomes 4 and my right becomes 1, 2, 4, 6. So my left and right both are not equal to so in the last operation my shift becomes 1, right? In the last operation when I removed these two bits, I have moved all the bits to right. Okay, so that's the reason now my 1 becomes this, 2 becomes this, 4 becomes this, 8 is this, 16, 32. Okay, so now I'm going again, my left and right are not equal to left and right are not equal to each other, right? So I'm again going to perform the right shift operation, and now this time I am going to remove these bits. Okay, so I have removed these 2 bits. So now this becomes my 1, this becomes 2, this becomes 4, this becomes 8, and this becomes 16. Okay, I have performed the right shift operation. So now what is the output? Output is for my left is nothing but 2. Okay, 2 bits is set, and for my right the output is 3. Okay, 1, 2, so total 3. So again my left and right are not matching. Okay, so in the last operation I have already updated the shift to 2, right? So now again I am going to move my shifts one step more, right shift. I am performing the right shift on my bits. Okay, so now my left and right are going to look like this. So this so here perform the right shift. Okay, so now all the bits are moved to the right. So now what's going to happen here? Okay, so here one second. Okay, so it's good like this only. Okay, so here what is the output for the left? What is the output for the left? Output for the left is 1. What is the output of right? Right is also 1, right? So now both left and rights are matching. Okay, both left and rights are matching. And how many times we have performed the shift? This is 1 time, this is 2nd time, this is 3 times. Total 3 times we have performed the right shift. Okay, so shift I am making the count here. So this bit we have removed, performing right shifts. Performing right shift on both left and right. This 2nd time performing right shift on by 1 on left and right. So total 3 times. Okay, total 3 times. And now we get both left and right are equal. Now what I'm going to do, I have got the number shift is 3. Okay, so I am going to just pick any of these now. New, left or right, I can pick any one. I can pick any number, left or right, because both are same in this now. So if both are same, now I am going to perform left shift. I am going to perform left shift. Previously I was performing right shift. Now I am going to perform left shift on left or right by how many times? By this shift times. So here shift, I right shift. Okay, so my left is nothing but 1 in last case. So I can write 1 like this, 0 0 0 1. Okay, now this is 1, this is 2, this is 4, and this is 8. Okay, now let's perform the left shift. So when I am going to perform the left shift, so my numbers are going to look like this. So I have deleted this, so now my number becomes like this, 0 0 1 0. Again I perform the left shift, so now my numbers looks like this. Okay, 0 0 0. So this is shift one time, this is shift I performed second time. Now shift is 3, so I have to perform left shift by 3. So now last time I am performing the shift, so number my now looks like this. So this is going to be output, right? This is 8, this is nothing but 8. Okay, so I hope that you guys are clear with this approach. Okay, so now code is of just 2-3 lines. So let's write the code like this. First, int initially set the shift to 0. Okay, then I have told you that I am going to perform one while loop while my left is not equal to right. In that case, I am going to shift the bits of left to the right by 1. Okay, so left is nothing but left is equal to left, right shift 1, right is nothing but right, right shift 1, and I am also going to make counting the shifts that I am performing, the number of shifts. So here, and in the end just return left and perform a left shift to the how many times? Shift times. Okay, so now let's run it and see. So all the test cases has been passed. Okay, so now let's submit it. So our solution is accepted and beats 100% of users with Java. See, so this is very simple, right? So I hope that you guys are clear with this explanation, right? If you guys still have any doubts related to this approach, then please feel free to ask in comment section. Okay, there is one more approach in which we can solve this problem. Okay, so I'm just going to write that approach. So here we don't need to do this. Okay, this is also best approach, so you can perform this. Okay, so runtime is also very less, and see here just 3 milliseconds, and this is the best solution. This is also one of the best solution, and you can also solve this problem like this. Okay, so here while my right is greater than left. Okay, if this is the case, then in that case I am going to update my right as right, performing the bitwise AND operation between right and right minus 1. Okay, right minus 1. Okay, and that's it. In the end, in the return, I have to just write right and the original number left. Okay, so now let's run it. I think there is some yeah, see here, this here I should write greater than I mark question mark. Okay, so run. So all the test cases has been passed. So now let's submit it and see the runtime for this one as well. So I think it's same only. Let's see. Yeah, mostly it's same. No, but previous approaches. Okay, let me submit it again. Let's see what happens if I resubmit it. So now it is giving a runtime 3 milliseconds and it beats 100% of users with Java. Sometimes this happens in LeetCode, I don't know why. So here what I am doing, so here let's understand this with an example only. Okay, so this is my code, and here let's take again left as 9 and right as 13. Okay, so my right is greater than left, yes. So after that I am updating my right as right and right. Can I write? Okay, 1. Okay, let's take 16, 8, 4, 2, 1. I can write my 13 like this, right? 8, 4. This is the way I can write 13. Okay. Okay, now write and write minus 1. So write minus 1. So write minus 1. Let's perform write minus 1. So what is my write? Write is nothing but 13 minus 1, 12. So can I write my 12 like this? 0, 1, 1, 0, 0. So here what is the output? So my output is 0, 0, 1, 1, 0. Okay, this is my output. So what happens here, I reset my rightmost bit. So now my new write becomes this 12. So this is my new write. New write is nothing but 12. Okay, I reset my rightmost bit. Okay, so here my write becomes this one, and my write now 12, left is 9. So 12 is greater than 9. Yes, it is true. Then again I am going to perform this while loop only. So here write, this is write minus 1, that is 11. So I can write 11 like this, 0, 1, 0, 1, 1. Okay, so now what is my output? This is 0, this is 0, this is 0, 1, 0. So this is nothing but 8. Okay, here I again reset my rightmost bits. Okay, again I reset the rightmost bits. So now my new write becomes 8. Right, now 8 is greater than my left. No, in that case I have to just return my right and left. Left is originally what? 9. So 9, I can write 9 like this, right? 8, this bit, this bit, this bit. So what is the total output? Total output is this 0, 1, 0, 0. So this is nothing but 8 only. This is nothing but 8 only. Okay, 8 only. So this is my output, right? So here also I am just trying to find the common bit. Okay, and that's the case. We are just only find the common bit and then returning the result between the right and left. Okay, so I hope that you guys are clear with this approach as well. And yeah, I have already told you. If you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you in the next video. Thank you. Bye bye.